and then I'll say something about Tclquadcode.
Yeah. Maybe I want to remind, because I was asked by one or two guys, after the talks of Donald, we will have an open discussion. If you want to go to your hotel, you will have, I think, enough time, so you will be here at 6 o'clock. At 6 o'clock we will start walking to our social event location. So if you don't have to go to the hotel like you can stay here till 6 o'clock. The others, please, as long as you take 10 minutes, 15 minutes, leave and come back. So you are here at 6 o'clock. So Don, please.
Okay. Just as a start of this, just to mention that this is actually an interactive session. If you have any questions, please ask immediately. I don't want you to just save them all up for the end. So I'm going to start out by talking about the status currently of Tcl and Tk. So at the moment, I'm going to start out by mentioning that 8.5 is currently on long-term support. So we're basically expecting that we're not really going to do much more with that. We still support it. We'll still answer questions on how to use it, but we're not anticipating doing any significant releases for it in the future, except for one when we finalize whatever minor bug fixes we happen to know about. That just as we did with 8.4. So we would recommend at the moment that people use 8.6 for anything that is for production use. It is our current main release. We've basically stopped accepting new changes for 8.6. You need permission from the TCT in order to actually have a tip that actually goes forward onto that. Otherwise, we'll just change it to be going for 8.7. There's only been 2 tipped changes to 8.6 in the last year. One of which was basically a bug fix in an API, and the other of which was actually revising the build system on Windows. I mean, that almost didn't need to be going through the tip process at all. So if we look forward to actually going forward, then for development, the first thing is that the tip website has now been moved to a new site based on Fossil. But with 8.7, that's now open for new features. And it's currently in alpha. We've already got one alpha of 8.7 out. I'm anticipating that there will be another alpha released this year. And that's got quite a lot more new features since the previous alpha, so that's good. And we've also opened, we have a branch open, it's actually the trunk is open for things for 9.0. And at the moment, that's just really compatibility breaking things, and there's not really very many changes on there yet, other than tracking 8.7.
9.0 is, as far as I know, only on Tcl.
Yes, at the moment there's no plan. At the moment there's no particular plan to do a 9.0 for TK. If TK makes changes internally that make it so that it's incompatible with previous versions, then of course we can have a 9.0 for TK. I mean, but there's no requirement anymore for the versions of these to remain in lockstep. We're very pleased that we got rid of that one because there was no real reason to have it.
What happens if Tcl 9.0 includes or contains incompatible changes that affect TK?
That's a good question. A particular, we're looking for 9.0. It's probably going to be mostly API compatible, probably not ABI compatible. I would expect that if TK is built against 9.0, then it will work with 9.0. If it's built against 8.7, it will work with 8.7, but it won't be the same build that'll be able to work with both. I can't say that this is necessarily true. I don't know. I haven't checked because I have not been doing much work against 9.0 or TK at this point. So this is the new TIP website. So as I said, it's a nice fossil repository. We've got it. We've done it as that because to make it much more accessible to Tcl developers. So I'm no longer quite such a bottleneck as I was. So all the tips are now formatted using Markdown. This means they can have images inside them. We can do attachments and all things like that. It works out much nicer. We have decent searching using full text searching. So, and you can also do filtering of the index so that at least on the few basic things, so that it's easy to narrow down to what are the tips that are interesting, which is particularly useful for me when I was writing this talk, because I needed to know just the things that were apply to 8.7, for example.
The keyword search sometimes leaves something to wish for, because I've had a few cases where I searched for some keyword which I knew was there, should have been there.
I know that what it is doing is that it's doing a full text search, and where the content that it is searching over is the content of the tips. So if it's not finding it, it's not. I don't know why. It's definitely just using the fossil content. It will also find the key. It also should find the words if it's in any commit messages and in other places like that. But usually it tends to be in the tip content. And certainly it seems to work when I've gone looking for it, but that's I do not know why it would not be finding something it's looking for. And I should definitely mention Mark Jansen for his humongous amount of work that he's put into making this work. It is substantially better than what was there before. So it's yeah. The coloring of the table is the dark blue ones are for things that are open against 8.6, which is to make them stand out. But I probably should put a key in there, but I haven't done so. But yeah, all the coloring is done with just bits of CSS, of course. But yeah, I should do something about that. It would be nice if somebody put an issue in somewhere for me to actually remember to actually do that. It's just fiddly. Okay. So, things that are new in 8.7 so far. Not the final word on this by any means. So we have new commands. We have array4, we have package files, and we have Tcl process. Array4 allows you to iterate over arrays, even very big arrays, but to do it efficiently. Package files it's there to be a debugging tool that when you do package require, then so that it can actually debug what it's actually gone through and loaded in the process of requiring a package. And Tcl process gives you final control over the kinds of activities that are being done by when you do exec or launch a pipeline, and you can do things like reaping the zombie processes and things like that can leave around. We also have new capabilities for quite a few commands. So we now have decimal literals that can be prefixed with 0D, just so that it's much more consistent with all the other ways of expressing literals in various bases. I shall return to this topic, that one, in a bit later, because we're going further than that with that in 9.0. We can now use commands to generate substitutions in regsub, which is going to get rid of some one of the main uses of subst, and one of the most difficult uses of subst that anyone actually will come across normally, and that's very nice for those cases where you actually need it. We now have a new unit, weekdays for clock add, which was demanded. We've updated the support for Unicodes so that we can have smileys.
It works in the core.
Yes.
If you use binary extents, depending on what the binary extension does, you don't magically get.
At the moment, such characters are encoded using surrogate pairs.
Yes,
and
the extension must be prepared to handle this.
It
should be said clearly that if you use binary extensions, you have to check if your application.
You need
to check if this works.
The most important, this first level of support for it covers being able to take in a UTF-8 stream from the outside world, pass it through Tcl through basic processing, and then send it back on out to files and stuff like that. And that was the most important first basic thing. Because without that, even simple things were going to be a major problem. We still need to do more work on this, and some of that work will be lasting through into Tcl 9.0. It's going to take quite a long time to untangle all the bits and pieces of that. We also, the other thing I will mention with the new capabilities is striding list searching. So it's just like we have striding list sorting, we now have it for searching as well. So it's just making that just more uniform in the capabilities between those two commands, because they're so often used together. Have some changes to Tcl. We have private methods now and private variables. That took a stupid amount of effort. We've made it much easier now to script your own definition commands. And we now have control, and we have control over objects namespaces in OOcopy, which is generally just nice to be for the people who want to be able to specify a namespace which an object has. If you want to, there's a few use cases where they want that. We provide that capability. We also have some other standard package changes. So the Messagecat package has had a few changes. It now supports custom locale search lists, and it now can work correctly with Tcl classes. The idea is that with that is that a class is part of a package, and therefore the namespace that you will be looked up with that is the namespace that contains the class. Not you, and it gets that part right. Whereas before it was, and you would then end up looking inside the implementation namespace and things like that, and that was all completely wrong. We also have updates for Tcl test, so that optionally you can get the performance measurements out of tests. Now, I would emphasize that if you're doing this, then your performance measurements are, you have to have very tight control over the test environment in order to get reproducible performance values out. So this is not something that is going to be something where you're going to say, this thing must absolutely be faster than that. It's not a test requirement, but it is a way to be able to actually track what is the performance of tests.
How is it implemented? It's using wall clock as time? Or?
That would be using wall clock time. It's basically just using the time command. So, one of the biggest changes is been the rework of the notifier. So now that we can support the epoll and KQ system calls as ways of implementing the notifier. It's a configuration time option which one Tcl will be built with, and this makes Tcl considerably more efficient on when on platforms that use these, and it means that Tcl process can support far more open channels than it previously would do. This will still use the old notifiers on some platforms. Windows and OS X have their own notifier anyway, and very old Unix, well, it might still be using select. We still support that, but if you have something better, and I would think, then we should be then using it is better. And certainly there's some things there. We are making it so that threaded builds are going to be the default turned on for everybody. This is because there is a considerable amount of problems with when you have unthreaded builds making processes with threads, and you get some bizarre bugs when you see that. In order to, we are working towards the point whereby we're going to actually just having thread support being on all the time for everybody. That's the end goal. At the moment, when just having it so that if people want unthreaded, they have to actually explicitly configure that. If they just use the default options, it will be threaded. This is the reverse from how it used to be on Unix.
If I understand, the plan is to drop non-threaded support completely.
Eventually, yes.
Well, I accept this, but I understand the reason. There are extensions out that have special support for threaded Unix. They need then a new configure option. You always have a threaded Tcl. The threaded options of the extension package may mean more overhead, so you want to give the user the possibility to build.
Basically, with the threaded build, the main changes are when you have a threaded build, it uses a different memory allocator, and it uses a different way of managing what would be static data. So that it moves it effectively into thread shared variables. This prevents a lot of bugs, but it doesn't. But the particular problem which we've actually been running into is with, particularly when people embedding Tcl in Python processes, which are threaded, but there's been a lot of problems with people who have been taking an unthreaded Tcl, embedding it in a threaded Python process, and then things just break bizarrely. And then we get support questions about it, and saying, and everyone, and they're convinced they've done nothing wrong, and whereas in fact what they've done is they've just broken everything completely. We're trying to nail that particular door shut. Of course, on some platforms, threaded builds are the default anyway. Because they're an intrinsic part of how the notifiers work there.
So, what are the details about those nasty bugs?
Which nasty bugs?
What happens when you embed an unthreaded Tcl into unthreaded program?
I can't remember exactly. You get some really strange. Get really strange things with, usually involving segmentation violations and other hard to reproduce issues. And you just get the most bizarre support questions, and it's just, and ultimately it comes down to people doing something they shouldn't have been doing. If you want to if you have a multi-threaded process, then really it should be a thread-aware Tcl. It's not to say that you have to use the thread package or anything like that, but it has to be thread-aware Tcl. Otherwise, because that's the only way we actually support safe access to an interpreter and that's how it's going to be.
So to phase out after the Tcl.
It does mean that a number of complications, particularly for Tcl X and expect. Yes. because one of the things we're going to probably have to do as part of a consequence of this is make sure that signal handling works. And that may mean that we actually have to build signal handling completely into Tcl's core so that we can just say, this now going forward is how to do it, and we've done it correctly for everybody. That may well be the right way of doing it. I'm not going to...
Well, that would in fact be concerning now. Signal handling completely in Tcl.
Well, that would be quite nice. I've only wanted it for 20 years. Yes. But that isn't done yet. That isn't done yet. There's also quite a few low-level changes. We've merged some internal types. We've improved the consistency of scan and printf. Should be scan and format, really. Anyway, there's improved the format consistencies. There's some improvements to TCP server creation. And Panics can use non-ASCII on Windows. Oh, I'm so thrilled at that. Who knows, we may even be able to do little frowny faces when Tcl crashes. Also, we're expiring the support for a number of things. Some things we're just getting rid of because we don't do them anymore, actually. No, we don't actually care about maintaining source compatibility with Tcl 8.3. Nor do we care about supporting Windows before Windows XP. Yes. And we're getting rid of the HTTP 1.0. If anybody's still using that, please switch to HTTP 2. And we're also getting rid of the identity encoding because that was permanently wrong.
So is the identity encoding, if you were to send the encoding of a channel to that, write out to the file, would you get the special null representation?
Who knows? You might do, or you might not. The problem is that the identity encoding is thoroughly broken. It allows you to create ill-formed strings and things like that. It is actually, thoroughly wrong.
Yes.
And for the cases where it is needed in testing, it is far better to have a special testing command for generating stuff than it is to have it as a general encoding.
So recently I was thinking about writing internal TCL strings out to files so that I could use inmap to have a file back to TCL string object. And I think identity might be required in order to do that.
No. What you would want to do is you would want to have that as being a byte array. But you want to have a you want to have a file-backed byte array. But then that's binary data. And then you can pick pieces out and then you should be able to actually just handle that. Then encoding convert them or whatever. That's up to you. But I would expect that an M-mapped thing would look like a byte array, not like a string. Of course, byte arrays are a kind of string, but it would expect it to look like a byte array. The identity encoding means that you can put some really bizarre things in there, and it was always a bad idea.
I agree that it's a tool you can shoot yourself into the feet.
It's nearly impossible to do anything else with it, actually.
Also,
The last major use for the identity encoding was when it was the default encoding if the automatic encoding discovery failed. But we fixed that quite some time ago, so that if encoding discovery fails, now it defaults to ISO 8859-1, which is good because, in fact, that's one that preserves the that with that one character is 1 byte of what it actually received, and everything's correct all the way through for there. Whereas with the other one, you end up with ill-formed Unicode and weird stuff like that, and that's something that people really shouldn't be wanting. So there are a number of features that, I mean, there's a whole huge list of features which are currently targeted at 8.7, but the ones that I think are particularly interesting is zip file system support, even just read-only, so that we'd be able to have scripted documents using standard tools, and that will be, and all I need to do is to persuade someone to stop fiddling around with stuff and actually commit to deciding where things should be mounted, and then that'll be ready for voting. So I intend to twist Sean Woods' arm. I think we'll have type assertions and aliasing assertions, so that we'll be able to say more clearly that this value must look like an integer, or these two variables must be different from each other, and things like that. I mean, these things are assertions that it is entirely meaningful to make, even without Tclquadcode. Yet they're inspired by the kind of reasoning that we can do in Tclquadcode.
Are there any reasons, apart from quadcode, where it really matters if two variables are actually the aliased?
That's it. I mean, if two variables are aliased, not normally doesn't matter, but hey, we'll be able. But if we can assert that they are definitely different, then it means that you know that when you set a trace on one, you're not getting a trace popping up on the other, for example, and things like that. Because traces and everything that's related to traces, they work not on the local variable name, they work on the endpoint variable wherever that actually happens to be. So, which might be local or it might be somewhere else entirely. That's the semantics of it. I think we're going to see in-place string and binary data modification. So this will be being able to efficiently replace a range of a string with another string, and that will work also for binary data. So that I think that will come in. And the thing which I'm working on at the moment is getting more Tcl features in there. So this is going to be certainly at the moment looking at getting the EuroTcl package from Tcl. It's taken a lot more work than I thought it would, but I think that's nearly done. So that will be nice, and I think I have some other ideas for stuff to put in there.
Who's working on the string and binary data modification?
Oh God, can't remember his name. You should look at the author. You find there's at least one tip on it, and you look at the author of that, and then that should be who should be working on it, and then you might need to chase them down and beat them up and to say where's your code. So, looking for what's new so far in TK 8.7, we have some changes to widgets. So now we can do this sort of placeholder text for the various entry-derived widgets. So this is across both entry and spinbox and TTK entry and TTK spinbox and TTK combo box. And that's 5 different widgets, and they've all got this placeholder text. It's a modern kind of idiom. We also have labeled progress bars, and the only thing to notice with the labels is that they're not visible in all styles. In fact, it turns out that they're visible in all styles except the Mac progress bar, which is for which is supposed to be really small, so that you can't actually see anything there. But that's just because that's the platform style. We have other new features in there. So now we can snapshot a canvas as a photo image. So that's a different way of doing a way of writing a new photo image, so that you can take your image, then display it on a canvas, draw over the top with just whatever features, whatever canvas utilities you want. Don't know if this includes putting widgets on top. That I'm not sure about. But for all the other features, you can just draw them on top. Then you just take that and then convert it back into an image. And I think that's and then save it or use it as a label or whatever you want. We have some changes to introspection. So for TK Busy and for the text widgets undo and redo mechanism. And we got some really old tips that have actually finally managed to be implemented and get in there. So just because the tip is old doesn't mean that we're not interested in having the feature. So now we have the ability to control the alpha channel properly, even if just on 1 pixel at a time. And we've changed the default tear off option to false.
Yes to that.
I don't think anybody for decades has really wanted the tear-off option to be true by default. And these features, I had my Thunder stolen. So SVG support and RBC, and these are the things I think that will make TK 8.7 a very exciting release if we can have them. If Tcl Path makes it as well, I think that would be brilliant. I would love to hold someone. I will hold someone's cloak whilst they work on these things. I'm very supportive of this.
Another question about tip 466, replacement of the text widget. How many things there? I think there was implementation already there, then nothing happened. I'm not immediately aware of the status of that, whether it's actually ready for a vote or not. If an implementation's fully there, then it should be ready for a vote. But it needs, as I recall, it's a huge tip, and that tends to. And the problem with huge tips is that they reach the point where they're very difficult to review. And there's just lots and lots of very small changes, and that's very difficult to review. But we should. I debated putting that on this slide. I did. I swear it. I just didn't. Because I think these are much more exciting things. How about the anti-aliasing?
Anti-aliasing on at least one platform, the canvas is already anti-aliased. So you cannot count on the canvas being not anti-aliased. So we can put we could technically put anti-aliasing in at any point and claim that we were being compatible. On Mac, the canvas is anti-aliased.
Yeah, on Mac. Okay. Whoever it uses, but
and has been since at least 8.0.
okay, I don't have a Mac, so why canvas looks like?
It's down to what the drawing API does. What it requires is replacing the current API calls, which are doing it through basic X11 or basic Windows drawing calls, and just replacing those with ones that will produce an anti-aliased line or anti-aliased anti-aliased polygons and things like that. Text is usually anti-aliased now.
Okay, so are you telling me that it is not much work to do, but or is this not done?
I'm saying it's actually quite a lot of work to do, but typically the way you would actually have to do it is by turning the drawing surface into something into an open. It might have to become an OpenGL surface or something like that, and then on that you would have to actually use an anti-alias drawing core.
The problem is competing on UI kits do it since 20 years, so we should really be able to do it.
Yes, and it needs someone to write the code. And it's not going to have people objecting to it happening. I would love to be able to, if next year I came here and announced that it's been done, that would be brilliant. Who's going to put the bell on the cat, I think is the classic. It's not enough to just say it should be done, you've got to say who's going to do it. And I do not have the spare time to do it myself. So, in changes so far in Tcl 9.0, there have been no changes at all for that would lead to there being a TK 9.0, I should mention. So the changes are that we've removed Tcl precision, or rather made it not special at all. So now you will always get the standard, the full conversion, and you won't have a choice on that. We've got rid of some old commands that nobody should be using, and some old syntax from some commands that nobody should be using. They haven't been, all these are things which haven't been documented for a long time. So if you were using them, well, that's just going to be tough. You shouldn't have been. We're getting rid of the use of VA list in Tcl's public API. Hardly anybody would have been using this, and I really hope that it was actually nobody. But it turns out that it's not actually portable. This was more of a problem on Windows than anywhere else, because the platform API actually depends on which compiler you're using. But that's we've got rid of some really horrible bugs in name resolution. It's still a horrible thing is name resolution, but it's not quite as horrible as it was. And we've got rid of the old style of octal constant. This is... Now, if you want an octal constant, you're going to have to put that letter O in there. And 0123 will be 123. Likely future changes. We're pretty certain that we're going to go through and make the sizes of things be 64-bit. Virtually everyone now uses 64-bit platforms for things. This does quite a lot of wreckage to the C API. But so this is an unfortunate thing, but on the other hand, it's in service of doing things right. And this will give us big strings, long lists, huge hash tables. Generally a very good thing, and we should have done it long ago. And I expect that we'll also do full Unicode support, including sorting out all the nasty bits and pieces, like the size of Unicode characters, providing Tcl commands for doing normalization and things like that. So no idea where all these bits and pieces will fit, but I would be very surprised if we didn't do that. And so, right. Now we're getting towards talking about Tclquadcode, which I think is sort of more fun. So any questions so far? Well, we've sort of been saying the questions as you go along, but anyone who wants to have questions about what I've said so far and hasn't yet spoken up? Okay, I'll go on.
At least one time frame for 9.0?
We have no planned time frame for 9.0.
Okay. No surprise.
At the moment,
What do we expect? 2 years? 5 years?
The year before Perl 6.
at the moment, most new features are going into our 8.7 branch. I strongly believe that there will not be an 8.8, and because but if that would be really embarrassing. It would say that we just can't get our act together. 8.7 is several years out, I would say. We're going to have our second alpha this year. Then there will be maybe one more alpha, or maybe we'll go to beta at that point. After that, which would probably be, so that would likely be next year. Since in practice we seem to manage to do about one release a year. And that, unless we can clone Don Porter. Once we get 9.0, 8.7.0 out, which will depend on how fast we can fix as many bugs as we can, and settle on on the set of features that we really want to have in as a strategic goal, then we will have enough effort to work flat out on getting 9 done. But we've started to do 9 now, so this will be getting in the things which I've already mentioned to do with having we will get the sizes and stuff like that, and all the low-level incompatibilities sorted out, so that when we come to actually doing the sort of big, the new features, then they should have a relatively stable platform basis in order to work, and they will already have. Hopefully, by the time we do the first alpha, then we will have most of the really nasty incompatibilities already sorted. Okay, so Tclquadcode. This is Kevin Kenny's and myself's little project to write a compiler for Tcl that produces native code, and it is to write an optimizing compiler. So it is the idea is that we want to compile Tcl and to get rather more performance out of it than people have tended to achieve in the past. So what we do at the moment with the project as it stands is we take scripted procs, usual sorts of things. We get the bytecode from it. So that's using the standard Tcl bytecode compilation that everybody's using. We translate that into, let's call it a better bytecode. And then we do some analysis on it so that we can add types and so on. And then we can do optimization based on that. And this includes doing optimization across procedures and things like that. Then we can take that and then feed it into LLVM, and then that will generate machine code out of that, and say it as a DLL or something like that. So our better bytecode is called quadcode, which is why the project is called Tclquadcode. It's not really a bytecode. It's actually lots and lots of nested Tcl lists and things like this, but it's like a bytecode, except that we haven't bothered with a binary serialization or anything like that. One of the key things is that it is using a static single assignment, which is a compilation technique, so that all the local variables actually become things that are only ever written once in the flow, and this actually allows us to do a lot of flow analysis. and that's the key to actually how we actually manage to sort out all the variable liveness analysis, to do lifetime analysis, to do type analysis and things like that. We've built a type system for Tcl. Everything's still a string, so that's still great, but in fact it turns out that all the other types are subtypes of string. So we can still say everything is a string. It's just that we've changed the meaning of what everything is a string actually means. So examples of this is integers. Integers are strings. It's just that integers happen to be strings that are written, say, 1, 2, 3. Well, that's three. It's either 3 digits or it's a number. It's just a matter of interpretation. Floats, again, Booleans, and we'll be able to have things like lists and dictionaries and all these good bits. And then at the end of all of this processing, we generate native code using LLVM. It's slow, but it's portable. It produces really good code out of it, and it can generate, and it supports key platforms that we're interested in supporting. I mean, that's the other key thing about it, is that it particularly supports the sort of x86 and 64-bit extensions. It also supports ARM, and those cover the vast majority of processor architectures that we care about in doing this. How big are the libraries? It depends very much on what the code. It is critically dependent on what the code is, because some operations are small, some operations are large. Well, the trouble is it's incredibly variable. But I can have a look when we get to the demo. Okay. So what we currently have working is that we support most byte-coded procedures now we've got working. We've even got a prototype of coroutine support. That's not yet hit the trunk of the project, because but we can do access to arrays. We can global variables up var. Most code actually seems to have a good chance of working. This is nice. And for things like I/O and stuff like that, we just call it a standard Tcl interpreter. We assume that's there, and that's going to be, and that will continue to be the case because it gives us a runtime. There's still a number of types that we need to do. We need to do big numbers because we haven't done them yet. The Tcl API there needs some fixing. We need to do something better with lists than what we've done at the moment. We need to do something better with dictionaries than what we've done at the moment. We have some support for those, but they are just falling back on just manipulating Tcl logs. And we have to do Tcl methods, lambda terms. We'll probably never get to doing just random top-level code. We'll probably never get around to doing that. If you want speed, you're going to have to write some procedures or something like that. It's usually what people have to do anyway. Okay, so let's do some demoing. So, now I just want to check my, what should I do? Okay, so. Okay, so. What version have I got? 868. That will do. So, package, acquire, EuroTcl demo. Okay, so there we go. I've loaded a little package. I'll show you the definition of that package in just a few moments. But it implements a command called Fibonacci.
You should have picked 2018 as version number.
I could have done. So Fibonacci of 10, 55. Fibonacci of 20. Right. Fibonacci of 30. That took a bit of time, did that? The reason is it's a very, very stupid recursive implementation. So in fact, if we were to go and time Fibonacci of 30, we would see that in fact it's taking over half a second to compute that, which is quite slow. Of course, this is a stupid way of doing it. If you were going to do it for real, then you would then use a different technique of calculating this. But for a demo, it will do fine. Right, so let's compile this. I'll just double check my notes. Okay. Okay. So now that's running the compiler. So we just now built. We've now it's built it and it's plugged it into the package index I've got in that directory. So now I shall just save and paste that now. Next, now I do package require demo. Okay, now so I can still do Fibonacci of 10 and Fibonacci of 30. Oops, that's a bit faster. Let's time that. And that's got it down from half a second to less than 10 milliseconds. And so if I go over here, so
Can guarantee to speed up by a factor of 50, then we
again, it is critically dependent on what the code is doing. Numeric code tends to do very, very well, whereas string code might get 2 to 3 times as fast. Tcl's actually got quite good string handling code already.
Yeah. How would Fibonacci behave if the resulting number exceeds the 64-bit range?
That's why we haven't done big numbers yet. I did say.
Okay.
This is stuff to do. The size of the code it's generated, it's turned 200 bytes of Tcl into 21 kilobytes, or thereabouts. So there we go. That was built just a few seconds ago, and but we can always go through and add some more code. So what shall we do? Come on, let's write some code. Come on. It's time for someone to suggest something. Oh, come on. I got to reinvent something. Okay, let's area of circle. Global point. No, I don't want to do a global. Set pi 3. Pi times r squared. Yes, but I want to try and avoid using loading too many external things. Anyway, there we go. That's a very simple thing, right? Let's go. Okay, so area of circle 3. So that's like that. So time area of circle 3. So that one we could do with running quite a few times. So let's do that times. Okay, so that's going to take about 0.59 things. Okay. It's probably not going to get a particularly good sort of speed up, but it's simply because it's actually already really fast, and you end up with issues with the overhead. But no. So, okay, now. Okay, that's still producing the right sort of answer. Let's see how sort of. Oh, well, it's reduced the time a bit, but it turns out in this case there's quite a lot of overhead because you got a bit just from running time and all that, and all the code to glue stuff into the interactive Tcl loop. So I think we ought to do another procedure in here that uses that. So let's have I turn lmap r list of, and then we're going to do area of circle. Oh. So there we go. That's just extending what we've done there, and then let's go now we'll do that, and then we're going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So okay, so that seems to be all working like that. So now let's go with time that. Okay, that's looking more like a decent chunk of time. So we'll rerun the compiler, and then acquire that. And now we can, let's see how long that thing takes now. Oh, that's got it. It's now going quite a bit faster, and you can see in this case that it's actually managing to do a little bit of cross-procedure optimization. The more procedures that you actually have that you can see at once, the more likely it is to be able to find decent optimizations across them. So one of the things that we're particularly proud of is that we don't need to do anything special to actually enable that. It's able to actually discover all these optimizations for itself. So that's actually one of the things that is very, very nice. TK is, at the moment, it's just an external, as far as this code is concerned, it will just be an external library.
The widgets are fast enough in C, but you can't just put any code into your box.
Yeah. It will just, for anything that it doesn't recognize, it will just call it through the normal Tcl interface. It's using normal Tcl global variables. It should all just, everything should just work. Yeah, so for I/O, for the most part, it does absolutely nothing to optimize that. The point is that it should be able to cope with those things. This is not yet tested with that. So I may be wrong, and it is definitely possible to find ways in which this code isn't going to defeat the compiler. When it comes to the more procedures that you compile at once, the downside is that it takes a lot longer to run the compiler. Because the more procedures the more functions it's actually compiling, the optimization is not linear.
It's compiled native compiled Tcl paths with normal Tcl paths.
Yes, I see no reason why not.
Just ask.
Yeah.
So you have
So
mathematical routines and Tcl, and you speed up with,
yeah. It generates Tcl commands. So it's just that instead of having procedures, you've got native implemented commands, and they tend to be fairly opaque in terms of the compilation. So one of the use cases that we've actually been thinking about is using this as not just as a way of speeding code up, but as a way of obfuscating code. So that with the fact that the Scriptix compiler is now open sourced, we can't actually count on people being able to use that as a code obfuscation technique anymore, because people can just get the code loader, and once you've got that, you can easily figure out how on earth to decompile the things. It's actually pretty straightforward. Okay. If you actually see which bits of Tcl you have to hack in order to actually make that work. It's not actually particularly difficult. It's just we only haven't enabled it in the past because by agreement, and it's not. Yeah. But yeah, but the aim with all of this is that to be able to you just have normal Tcl code and then be able to read it through a compilation. It should. We're hoping to add the type assertions and the aliasing assertions because they will enable us to generate better code. But it turns out that we can actually do pretty good things even if we just have, even with very basic code. So, because it turns out that we can do partial loop unrolling, and that allows us to actually do some clever things with types. So Kevin's done some really wonderful work on that side of things. So, yeah. And this is so the current areas of work that we're doing. We're looking at doing stackless evaluation and coroutines. I believe it's working, but with quite a performance penalty, which is I think mostly to do with the extra memory management that it does. We need to do more work on seeing what we can do to actually manage that. We have to do some work on removing static data in the implementation. The original design goal was to have this as a JIT, which produces one set of ways of implementing static data. But since we're switching to working with DLLs and stuff like that, that calls for implementing things in different ways. So there's quite a bit of work to do there. And we would like some better front-end APIs to the compiler. We would like to be able to allow analysis tools to be able to use some of our outputs. Maybe not so that instead of generating native code out of it, use it to detect things like bad uses of variables and stuff like that, which it turns out that we have that information as well. So that would be useful for a tool like Nagelfar.
Demonstrate it with the compiler.
Actually, yeah. Oh yes, let's.
Stuff that is known Tclquadcode and so one can give it a try.
Well, let's set x y plus z. That's going to fail really thoroughly. But let's see what actually happens when we compile that. I don't know what will happen, but it should. Maybe I haven't got the warnings turned on. Let's see, debug one. Ooh, it's generating lots of output. Okay, that's now thoroughly impenetrable. I can't remember how to get it to generate warnings out of that, but we have the information that these things are wrong, but at the moment, I think at the moment what it does is it will neatly generate the production of an error message. which is perhaps not the most efficient thing, but most suitable thing, but we have the analysis.
Exceptions are needed in the long run, of course, but mainly the question of the compiler to use the demo, I can get from the repositories and can put my code on it.
Well, you can. I mean, it's just in Fossil on Tclquadcode. So feel free to
Experiment.
Yeah, and the old active state stuff is now open sourced. I think that's on GitHub, but I'm not 100% sure about that. And yeah, we also want to enable analysis of some key external code. It would be great to have something like Vectical being able to plug into this, because that would be able to take very great advantage of being able to do this, because certainly LLVM has some very interesting vector operations, which certainly our code is not making any good use of, but it would be very useful for something like Vectical. And that's approximately where we are up to. We haven't done very much in the past couple of months because I've been busy with Tcl itself, and Kevin's just been busy with his family who have been having some health problems. So, anyone else have any questions or comments?
I've heard previous talks that switching to coroutines made people much slower.
Depends exactly on what you are doing. What happens is that it made the process of entering a procedure a lot slower. But it doesn't affect, if your procedure is quite long running and does a lot of internal processing, then it has no effect on that. So it depends on the exact profile of your code.
Will the new compiler have like pragmas where I can say I'm not using coroutines here?
Maybe, but we haven't done that yet, and now the last we had of it, we've actually got an implementation of coroutines at all, which was quite complicated because internally that is doing a lot of work so that it can generate it will take a Tcl procedure and splits it up into several different bits and pieces and then threads them together, and it's really, really, really complicated. So coroutines are non-trivial, let's put it like that. But we have it working, but we are not yet satisfied with the performance of them. So we haven't yet merged that code back. One of the issues is that there's several different objectives. One of the objectives is to be able to use extremely large stacks, for which doing this sort of stackless form is good. But another objective is to be able to run very, very fast, and for that one, you would actually be better off not having coroutines, because then and just using the C native stack. That is certainly when you're dealing at the machine code level, that is the fastest way of operating. We haven't yet decided what we're going to do about this, so that's because it might be that something where people have to actually specify something, but I don't know what we're going to do there. This is still, I would say, very much experimental work. Even if we can actually do some really cool things along the way.
Are there any plans to include the Tclquadcode in
the Tcl core, and in which version could be expected? If yes.
Long term, we would love to have it be there as part of. We would like to have it be there. We don't think we're going to be there for 8.7. We just don't have the effort to do that, and there's major functionality still missing, particularly methods. Methods would be a very big requirement, but also doing much more with lists and dictionaries. That would also be a considerable requirement, because in some particular cases, like being able to use dictionaries as structures and things like that. So that would do a substantial amount of performance enhancement and make better memory usage as well. And that's quite a lot of work in order to do that. But it is, I believe, fast enough now to be useful for some people in some circumstances. And certainly it was very, very interesting to the people at FlightAware last autumn. I've never heard so many jaws hit the floor in one talk as when we were showing that off. And it's, at the moment, we're looking very much at just trying to work out to support more Tcl functionality at the moment. I think and that's really where we're looking at. There's also the issue of needing to actually just keep up with Tcl itself, because we keep having new features in Tcl that would be actually useful to have supported from Tclquadcode. So at the moment, Tclquadcode is very much targeting 8.6, not 8.7. We know this is going to be an issue just in itself, because there's parts of Tcl's implementation which have changed, but it's still useful as it is, I think. And I think that's my last slide. So. And yeah, the more you do loops and things like that, the more the code actually shows up just how fast it can be. Because then and the other thing that we get from doing this is that you actually get visibility from debugging tools now of what's actually going on in Tcl. I mean, that actually is one of these things where you can actually go, oh, I can use a standard performance tool and things like that.
This demo procedure, was it originally intended to have an export inside, or is it really just assigning a literal to X to variable X?
Well, no wonder. That might explain why it didn't work. Okay. See if that generates. That still didn't. Oh, well, let's go through and, yes, and then you can actually see that what it's just generated here is that it's in fact it's the analysis that actually worked out that the only thing it can do is throw it. Is throw. So I'm not quite sure how to tell it to actually say that it should that it should actually spit the analysis out. But we can actually pick. We do actually do all that stuff. I mean, but that's certainly Kevin's been talking quite a bit about wanting to actually get the analysis part of our code to be able to help with things like Lowlevel. And yeah, you can see we generate an awful lot of code, in fact. a lot of debugging information in there as well. But yes, unfortunately, it's hard to demonstrate the code on something trivial, because you end up with actually what you're measuring is the overhead of just doing the calls and stuff like that. But that Fibonacci code does demonstrate that things actually speed up quite a bit.
Testing on macOS, how can I test on Linux, on
In order to use it, you need the Tcl, the LLVM Tcl from my fork of it on GitHub, which is the interface to LLVM, and then once you have that package installed, then you can take the Tclquadcode package, and there are some scripts in there for running things. One of those is this package compiler. There's another one, and the other big script that's in there is actually our test suite, which is one gigantic script, and it just compiles masses and masses of procedures which test out virtually all the features that we have so far. So that's which is a rather long Tcl script actually, and fairly boring, but hey, it gets lots of different bits and pieces of performance analysis done, and it's got a bunch of timing things in there. But and yeah, so if you want to use it, then you know, and you're having any problems, just ask. Yeah. Okay, I think that's the end of this little bit. I think it's now I think we can now have the general session. Light.
More light. Yeah, you don't have to.
Oh, you don't have to. Ah.
You switch off.
Yeah.